Hello and welcome to another Climate Tech podcast, Conversations with the people trying to save us from ourselves. In this episode, I spoke with Anastasia Krivoruchko, co-founder and CEO at Melt&Marble in Gothenburg, Sweden. We talked about designer fats, why lots of plant-based oils are destroying the environment, and why the US is a better market than Europe to launch new food products. I'm Ryan Grant Little. Thanks for joining. Anastasia, welcome to the podcast.
Thank you for having me.
So you started Melt&Marble way back in 2014, which makes you definitely a pioneer in the food tech space. What does Melt&Marble do, and how, if at all, has that changed in what's basically the past decade?
Yeah, so basically what our mission is to really facilitate the transition towards a more sustainable food system. And we do this by using precision fermentation to produce better fats for the next generation of animal-free foods. I think most people know that animal-based foods like meat and dairy are super unsustainable and really need to shift away from these foods to have any chance of mitigating climate change. But the problem is that most of the alternatives that are out there right now don't really give the same taste experience. So you don't get the same mouthfeel or juiciness with a plant-based steak as you would with a meat steak. And one of the reasons for this is the fats. The plant-based fats that are being used right now, they just don't have the same sensory properties that animal fats do. And with our technology, we can basically program microbes to take simple sugars and convert these sugars to animal fats like meat fats and dairy fats that give the same sensory experience. So the idea is to basically bridge this taste gap between animal-based and alternative foods.
And you say it's like fats, so it's still different than animal fats. It's not from animals, crucially. And I think my favorite term that I've heard in a long time is designer fats. What do you mean by designer fats? I'm picturing fat cells walking down the runway wearing Chanel, but that's probably not quite right.
Yeah, not quite, but maybe someday. No, I'm just kidding. So basically, this term is referring to the versatility of our technology. So what we can really do in a really good way with our technology is really program our microbes to produce any kind of composition of fat. So if you think about how fat is composed, it's specific kinds of fatty acids, specific saturations. And with our technology, we can really dictate how these fats are, or the kind of compositions that our microbes are producing, basically allowing us to replicate any kind of fat that is out there. Now, these fat compositions, they are basically dictating the functionality of the fats, like properties like sensory properties, melting profile, health profile. And using this technology, we can basically tailor make the fats to specific applications. So it's fats by design.
And this is because you're using precision fermentation, which is not a new technology. Precision fermentation is where most of our insulin comes from. Now it's been used in the medical space for quite a while, but we're seeing it more and more in the food tech space. Can you talk a little bit about what that is, what that process looks like, and kind of maybe a bit of a 101 on precision fermentation for food?
Yeah, so in general, precision fermentation, it's quite an old technology. It has been used, like you mentioned, to make insulin since the 70s. Even within food, it's not super new. So for example, rennet, which is this enzyme complex that is used to make cheese, that has been produced primarily via precision fermentation since the 90s. And precision fermentation has also been used to make flavors for a while as well. But what is new is these more recent applications in alternative proteins. So producing, for example, dairy proteins, producing animal-like fats via fermentation. So all of these applications are newer. And the reason that we have been seeing this kind of shift and new applications for this technology is because a lot of the fundamental technologies that underlie precision fermentation. So, for example, advances in genome sequencing, advances in DNA synthesis, synthetic biology tools, they have been developing a lot over the past years, and they have basically opened up a lot of doors for new applications of the technology. And of course, all of this being said, like right now, we're actually still in very very early stages of applications of this technology. So I think like in the future, as all of these technologies are developed further and further, we will see application of precision fermentation towards all kinds of products within food and outside of food.
When most people think of fermentation, they're probably thinking cheese, wine, things like that. Is that precision fermentation, or is that something else? Are there different types of fermentation?
Yeah, so precision fermentation is quite similar to like making wine. When you make wine or beer, you basically use yeast. The yeast takes sugars, it converts these sugars to ethanol, carbon dioxide, some flavor compounds, etc. The difference in precision fermentation is that, and of course, people define precision fermentation a bit differently, but typically you have like a certain element of dividing the metabolism of the yeast to produce some very specific type of compounds. So, for example, some companies are producing dairy proteins with precision fermentation. In our case, we are using a very similar process to winemaking, but we produce fat.
And we generally have been conditioned to think of fat in food as a bad thing. What's wrong with that interpretation? What's short-sighted about that?
So I would say that not all fats are created equal. So, of course, like you have, for example, trans fats that generally are quite bad for you. Then you have saturated fats that have been considered as mostly bad, but even that has been challenged recently. So now it's kind of not super clear. And then you have monounsaturated and polyunsaturated fats that are actually associated with various health benefits. So like, for example, brain health and heart health as well. And in general, you also need fats for just like normal function. So you need them to absorb minerals, absorb vitamins. Fatty acids are a key component of cell membranes. So like we would die without fats. So I would say like it's all about like what kind of fats we're talking about.
And so trans fats, we're talking about highly processed foods, potato chips, things like that. Saturated fats, it's generally animal fats. And monounsaturated and polyunsaturated fats, that's nuts, oils, and that type of thing. Am I getting that right?
So monounsaturated and polyunsaturated are usually oils. Saturated are usually more solid fats. But what you typically have in different food products is a combination. So, and then depending on like how much saturated you have versus monounsaturated and polyunsaturated, the fat will be a solid or a liquid.
And then does Melt&Marble's precision fermentation fat fall into one of those categories as well, neatly?
So we are primarily targeting solid fats because these are the fats that we need for our priority applications that are alternative meat and alternative dairy.
So I do some work in the alternative proteins space as an investor. And one of the complaints is that people have about alternative proteins or plant-based meats is that they don't have this kind of fatty taste. So are you creating an additive for, are you serving the Beyond Burger or being able to provide something analog to animal fats for that industry? Are you an ingredient for this industry?
Yes, yeah, that is exactly the idea. Because basically, like we are talking with like all of these players that are producing these alternative meats and asking them like, okay, like what is your problem with the fat? And typically it's, like it's the mouthfeel, it's the juiciness, it's, the melting. And these are the things that we are trying to replicate with the fats that we are producing.
I was interested also in reading some of your articles that you pointed out that some plant-based fats are really devastating to the environment. I think it's probably pretty widely known that palm oil has resulted in lots of deforestation. But I was surprised. I think coconut oil seems to have somehow dodged the bullet on the bad PR up until now, maybe. Can you talk a little bit about the problem with coconut oil and maybe any other under the radar plant-based oils that we might not think of as being problematic?
Yeah, so the reason that palm oil is bad is exactly like you said, it's linked to deforestation, and primarily palm oil is grown in like these tropical regions that also have like very high biodiversity. So it's not just that you're cutting down rainforests, but you're also threatening all of this biodiversity that is there. With coconut oil, it's actually exactly the same problem. It's also grown in tropical regions. It's also associated with deforestation and loss of biodiversity. On a per kilogram basis, it's actually a lot worse than palm oil because it's just not as efficient. So palm oil, with all of its bad reputation, is actually a very efficient crop. Coconut oil, because the market is so small, the overall effect that you see is, of course, like much lower compared to palm oil. But for example, I would not say that it's a good idea to substitute palm oil for coconut oil, because that would be less sustainable. But of course, like overall, this is also why it's important to have new technologies for fat and oil production, like fermentation, because with fermentation, we can produce our fats or oils anywhere in the world. So we don't have to produce them in these tropical regions. We can also produce them in such a way that is climate independent, weather independent, and of course has minimal land use. So it's a lot more sustainable overall. Yes, so the first product that we are working on is a meat-like fat to be used in meat analogs. So we're talking about alternative burgers, meatballs, etc. And right now we're in the process of basically scaling up the production. And the idea is to launch that product in the US next year. Of course, it's in precision fermentation, there's always lots of things that can be optimized. So it's, you can always optimize the composition. You can always optimize the flavor profile, taste profile, the process overall. But right now we already have like a pretty good process and product that we are happy to start with.
You're based in Gothenburg in Sweden, but you just mentioned you're going to be launching your product in the US. I've heard this from a few European-based food tech companies that they're launching in the US. Obviously, the US is a large market and a little bit easier culturally, linguistically to hit than kind of all of Europe. But I think also in some ways, the uptake is happening a little bit more quickly there with novel foods. We just saw a couple of weeks ago now that the US, the FDA has approved cultured meat for sale at the retail level. Are these considerations for you in terms of the first market? Is Europe lagging behind the US on some of this stuff?
Yes, absolutely. So for us, this is actually the main reason that we are going to market in the US first, because the regulatory framework in Europe is just a lot more complicated. So we have this novel foods process. And I mean, in general, it's good that like we have a framework, so we don't have to like invent something completely new. But that being said, in Europe, it is quite a long process. Right now, it takes on average around 3 years to get approval. And it's also quite rigid, meaning that once you submit your strain, your process for approval, there's not so much that you can do to change it afterwards. So, and with technologies such as ours, like you're always changing things, you're always making it more efficient. Like you cannot
3 years is a lifetime for this kind of R&D for sure.
Yeah, exactly. Like we cannot wait until like everything is completely optimized before going to market, because then we're going to be doing this for like another 10 years. So it's a bit more complicated in Europe.
So in the US, you're able to provide kind of updates on the product as the approval process goes forward. And is that with FDA, USDA? Who do you work with in the US for a product like this?
So for a product like this, we would work with the FDA. So we can actually get first this GRAS, which stands for generally regarded as safe self-affirmation, but then we can also submit this dossier to the FDA to get this letter of no questions, which is basically kind of like a certification that our process is safe.
Although you started the company about 10 years ago, you've been working on this topic even longer. So the company is a spin out from the Chalmers University of Technology in Gothenburg in Sweden, where you worked as a postdoc. What's the scene like there in Sweden? There are some pretty cool things coming out of the Nordics in general. Is Gothenburg and that university in particular a food tech cluster or a climate tech cluster, generally speaking?
The reason that I actually moved to Sweden to begin with, and that happened after I finished my PhD, was because I was very interested in metabolic engineering, which is the, I would say, more scientific name for precision fermentation. But basically, the application of microbes towards synthesis of all kinds of compounds in a more sustainable way. And I was looking to see who is doing good research in that space. And then I came across this group at Chalmers University of Technology in Gothenburg called the Systems and Synthetic Biology Group that was then headed by Jens Nielsen. And I realized that this is one of the best groups in the world in terms of research on metabolic engineering. Yeah, and Sweden seemed like an interesting place to go to after spending 11 years or so in Ottawa. So I decided to come over. And originally, I was going to stay for like a couple of years for my postdoctoral research. But then I really liked Sweden and Gothenburg and the research that I was doing. So yeah, a couple of years turned into 12, almost 13 years now.
Can you talk a little bit about some of the technologies that are coming out of that cluster there and what excites you about the food tech space in Sweden?
In general, within this group where I have been doing my research, the main focus of research has been on using metabolic engineering to produce all kinds of compounds for all kinds of applications in more sustainable ways. So this ranges from, for example, like pharmaceutical proteins, like insulin, flavors and fragrances, biofuels. Actually, this was how originally the research that went into our technology platform was born, because originally we were doing this research to produce biofuels, and biofuels, they are also lipids. So basically we have developed this technology platform for lipid production that was originally supposed to be used for biofuels, but then we also realized we can produce all kinds of other things with that in a better way. Yes, so these have been like the kind of main projects that we have been doing here. In terms of like food tech, I would say like in general, of course, like there's a lot of innovation happening in Sweden and Europe in general. Here in Gothenburg, we don't have so many companies. So we have ourselves, we have Microrena. There's on the Stockholm in Stockholm on the other coast, you also have some as well. But I would say like within precision fermentation, there could actually be a little bit more going on. But the reason that it's nice to be in Gothenburg for companies such as ourselves is this proximity to talent when it comes to microbial engineering.
How big is your team right now, and is it expanding?
Yes. So right now there are 16 people. Yeah, I think around a year or so ago, we were only about 4.
Oh, wow.
So it's and it's growing. So it's it's been fun like to see like all the like also having like people with new kinds of backgrounds and different kinds of expertise join the team. So at first, like we were just like microbial engineers, strain engineers. And now we also have like food scientists, for example, that are doing like this application development and also having like maybe sometimes different perspectives on the products compared to like the strain engineering. So it's really cool.
That's 400% growth in 1 year, if you look at it that way. And so what are the biggest challenges? What are the biggest opportunities kind of in the time ahead? I know the fundraising environment is difficult. I'm not sure if you're raising or not, but things are moving pretty quickly on, at least in the regulatory side, maybe not in Europe. What are you hopeful about? What are you worried about in the next, call it 12 months?
So I would say the biggest challenges, and this is true, like I think not just for us, but any kind of precision fermentation companies. So it's of course like to scale up fast, but also like do it in such a way that like you are delivering something that is good, and at the same time like also having like robust process that is cost efficient. So in general, like getting to like this kind of like cost competitiveness is a big challenge in the industry overall. And with precision fermentation, also like access to production infrastructure is also something that there is infrastructure out there, but there are also a lot of companies out there. And investment into own infrastructure is also quite a lot of money. So these are things that like really have to think about how to navigate this in a good way. I would also say like for the industry in general, like if we are talking about having any kind of significant shift towards these alternative products, alternative technologies, consumer acceptance, I think it's something that still has to be addressed. Because, of course, a lot of consumers, like they're interested in these products and new technologies, but there's also a lot of concerns from consumers that they are too techy And yeah, this is something that as an industry, I think we will have to continue tackling. In terms of the opportunities or like what is making me maybe hopeful is, of course, seeing the level of innovation in the space. I mean, like now there's like a lot of talk about how, like the space is slowing down and maybe it's like not as exciting as people were thinking. But actually, like if you look at like the progress just like over the last few years in terms of like the kind of products that are out there, like the kinds of companies that are out there, the kind of technologies, it's actually has been like really, really good. And of course, like you can't build Rome overnight. Like it's going to be a process. Like you're not going to have like the perfect, like most delicious, most cost-effective product right away. But I think in general, the industry has been making this really, really good progress. And it's also really exciting to see like all of the entrepreneurs and companies like doing like these really innovative things and having like this kind of passion for the space.
Yeah, the industry seems to be following the hype cycle kind of perfectly, and we're just emerging from, I think it's called the Valley of Disenchantment now, and getting to kind of more long-term commercialization. Last question. So you spent many years as a scientist. You still are a scientist, but you spent many years presumably kind of working in the lab. Now you're managing a team, you're selling products, you're raising money. What advice would you have to someone who's looking to make the transition from working kind of purely on the science side to becoming a founder?
Yeah, I could probably come up with like a list of advices. But I would say one thing is that like find people that can help you. So coming out of science, you don't know anything about, like accounting, let's say, you don't know everything about fundraising. So just, like approaching people at your local innovation office, or like maybe finding like other potential co-founders that have a bit of experience with that's really helpful. And I would also advise not to do it alone. So like having somebody that like you can really like talk to when things are crazy, like when you need to vent, or like when things are like going really well, and then you can share your happiness. I think like this is like super, super important.
Anastasia, thank you so much. It's been a pleasure talking to you.
Yeah, thank you.
Thanks for listening to another Climate Tech podcast. Please take 5 seconds to send this episode link to a colleague or friend who you think might be interested. Reach out to me anytime at hello@climatetechpod.com. As you can probably tell, this episode was produced, edited, directed, stage managed, boom operated, and everything else by me. Subscribe to hear many more conversations still to come with the world's real climate tech heroes.